What if the sun disappeared for just 1 second? Part 1. The first second of great silence. You're standing in the middle of a calm, gentle morning. A breeze stirs the branches. Sunlight filters softly through the leaves. And then, in the blink of an eye, everything vanishes. Not an eclipse, not a cloud, but the sun itself, the vital heart of the solar system, has disappeared completely for exactly 1 second. No light remains, no mass remains, not a single trace. Neuroshirexia. Is light immediately interrupted? First, we must understand, light doesn't reach us instantaneously. The distance between the Earth and the Sun is approximately 149.6 million kilometers. It takes sunlight 8 minutes and 20 seconds to travel that distance, meaning if the sun suddenly vanished, we wouldn't notice it right away. For the next 8 minutes and 20 seconds, every ray of sunlight emitted before the sun disappeared would still be en route to Earth. We would still see the sun in the sky, still feel the warmth, still observe shadows, the wind, the light. Everything would appear normal. If the sun vanished for 1 second, what would actually happen? A shadow zone races toward us at the speed of light. If the sun disappeared for exactly 1 second, what would happen to the light it was supposed to emit during that second? Answer: it never existed. That absence of emission creates a gap in light, a darkness about 300,000 kilometers long, the distance light travels in 1 second. It would be like a blade of shadow, a black light gap, hurtling through space toward Earth at 300,000 km/s. When it arrives, 8 minutes and 20 seconds later, the sky would go completely dark for exactly 1 second. No shadows, no beams, no reflection. Then, as if nothing ever happened, light returns. This is a scientifically valid phenomenon based on the mechanics of light propagation in a vacuum. Would you notice it? 1 second, a moment so brief that most human nervous systems wouldn't register it. But as if you were filming, if you had a hypersensitive light sensor, you might observe a single frame completely black. Then everything returns. No interruption, no explanation. That raises the question, did the sun truly vanish? Or was it just a sensor malfunction, a glitch in your brain, or a tear in reality? Dökfun, not just light. What about gravity? According to Einstein's general theory of relativity, gravity is not around a simple pulling force. It's a curvature of space-time caused by mass. If the sun disappears, its mass and its gravitational influence would vanish with it. But like light, gravity doesn't act instantaneously. Under current models, changes in gravitational fields also propagate at the speed of light. So, 8 minutes and 20 seconds after the sun's disappearance, its gravitational field would no longer exist at Earth's position. At that moment, Earth would no longer be held in its smooth orbital curve. It would begin to drift. Following Newton's first law of motion, inertia, an object will move in a straight line unless acted upon by an external force. Earth, once a planet orbiting its star, would now become a bullet launched into deep space. This is a logical projection based on accepted physics. It has never been tested in reality because no sun has ever disappeared. Suashimasho. If the sun came back after 1 second, would the solar system be okay? This is where things get complicated. If while the sun returned to exactly the same place, with the same mass and state, then light emission resumes after 1 second of absence. Gravity reconnects after an 8-minute, 20-second delay. Planets may return to their original orbits or close to them, but during that 8-minute, 20-second window, Earth had already veered. Earth, drifting in a straight line, no longer aligned with its previous orbital curve. When the sun reappears and gravity returns, it pulls Earth back, but now into a new elliptical orbit. Possible consequences: the year may become longer or shorter. Seasons might shift or vanish altogether. A new ice age or an era of desertification might begin. No simulation or astronomical model exists to verify exactly how Earth's orbit would respond to a brief gravitational interruption. Bummer, system error, or a tear in reality? If you were the only one who saw the sky go dark for 1 second, if no camera recorded it, if no sensor detected it, and if no one else could confirm it, then what was it? A moment where you slipped outside of reality? A glitch in the simulation? A bug in the cosmic code, and you saw what no one was meant to see? I cannot verify this. It is a speculative possibility within the realm of unproven theoretical models. Let me know if you'd like this as a formatted document, voiceover script, or continue with Part 2, The Return from the Void. How does the sun come back? 1 second has passed. The sun, the most stable source of energy for billions of years, has suddenly reappeared, as if it was never gone. But the universe, the laws of physics, and the sun itself, are they truly intact? What is the sun's internal state? The sun is a gigantic ball of plasma, more than 1.39 million kilometers in diameter, where constant nuclear fusion reactions occur between hydrogen and helium. Core temperature, 15 million degrees Celsius. Pressure, over 250 billion atm. Every second, about 600 million tons of hydrogen are fused. The pressing question is, if all of those nuclear reactions were interrupted for 1 second, what would happen inside? Internal pressure. Instability, fusion reactions maintain a balance between outward pressure generated by released energy, inward pull from the sun's own gravity. If the reactions pause even briefly for 1 second, outward pressure drops. The sun's core begins to collapse inward. Gravity takes over. Internal pressure spikes rapidly. When fusion resumes, the highly compressed plasma may trigger an energy recoil explosion, releasing anomalous radiation burst spikes in high-energy particles. It has not been confirmed by direct observation. There is no precedent for a star shutting down and restarting within a second. Energy flare-up, a storm of 10 million magnetic fields. If the sun's return is unstable, the next effects could include disrupted magnetic fields, massive coronal mass ejections, CME, sudden surges in X-ray and ultraviolet radiation. Historically, the most powerful recorded solar flare, the 1859 Carrington event, caused widespread failures in telegraph systems across Earth. A sudden jolt after a 1 second shutdown could potentially trigger an unprecedented solar eruption. Consequences might include disruption or destruction of GPS satellites, severe ionization of the ionosphere, total global radio blackout, overload of high-voltage power lines, gravitational waves, warnings from the fabric of space. Einstein predicted that if mass is suddenly redistributed or removed, it creates gravitational waves, ripples in the fabric of space-time. Sun disappears, space-time curvature collapses, sun returns, curvature reforms, gravitational waves emitted. These waves would have low frequency but long duration. The potential to travel hundreds of light years. Can we detect them? The Laser Interferometer Space Antenna, LISA, planned for launch in 2037, could possibly detect such signals if they occur nearby. The sun is back, but Earth has drifted back to Earth. For 8 minutes and 20 seconds, Earth has been moving in a straight path, no longer in orbit. At an orbital velocity of 30 kilometers per hour, it's now veered from its familiar elliptical track. When the sun returns and gravity resumes, Earth is pulled again, but not to the same point. Earth may now revolve around the sun in a more distorted, unstable orbit. Distance from the sun fluctuates. Seasons lengthen or disappear. Temperature swings of tens of degrees Celsius. Impacts on monsoons, ocean currents, biological rhythms. A cascade of secondary effects begins: seasonal shifts, ecological imbalance, unpredictable climate change. Other planets are not spared. Not just Earth, other planets are affected too. Mercury, closest to the Sun, suffers the most deviation, possibly spiraling into the Sun if gravity is not restored perfectly. Mars' thermal imbalance could trigger renewed geological activity. Saturn and Jupiter, massive gravity, could amplify dangerous resonance effects. If planetary orbits are misaligned enough, planetary collisions may become possible, not immediately, but within thousands of years. A long domino chain, all triggered by one missing second of the sun. Part 3, a crack in reality. Has it already happened and you just didn't notice? You blink. Everything looks the same. The sky is bright. Trees are swaying. Time on the clock ticks forward. But do you feel something is off? Maybe you once saw the light flicker for just a second and thought it was a passing cloud. Maybe you felt a strange drift and blamed it on fatigue. Maybe the sun had already vanished, and you were merely a witness who didn't realize it. Nigger, who could make the sun disappear? In known physics, there is no technology capable of removing a star from space-time for 1 second, making millions of trillions of tons of mass disappear without producing significant gravitational waves, reconstructing a nuclear plasma sphere at the atomic level in an instant. But if it has happened, perhaps someone or something possesses technology far beyond our current understanding of physics. For one, hypothesis, extraterrestrial civilization. Kardashev type 2. According to the Kardashev scale, a Type 2 civilization can harness the entire energy output of a star, control and or even hide its light and gravitational influence. A megastructure, such as a Dyson sphere or equivalent, could theoretically encapsulate the sun and Uranus, mask it from view for exactly 1 second. However, there is currently no evidence of such a structure existing around the sun. Hypothesis, a simulation. Glitch according to the simulation. Hypothesis proposed by Nick Bostrom. There's a high probability we are living inside a computer-generated simulation, operated by a more advanced civilization. If the sun is merely a rendered object within that simulation, a temporary or system error could turn off its display for 1 second. Both light and gravitational data would disconnect, then be restored. Those located at the right observational coordinates might detect the anomaly, but if most people don't notice it, the system recovers successfully. This is speculative and has not been confirmed by any verifiable evidence. Darsekson. Why does no one remember? If the sun really disappeared for 1 second, why isn't it recorded anywhere? No headlines, no global alert, no questions asked? Fuakudurin. Human perception limits. Humans only consciously register light changes lasting at least 13 to 16 milliseconds. 1 full second might be interpreted by the brain as a simple blink. Like walking into a tunnel, your eyes adjust within seconds, but your mind tells you nothing strange happened. Unless you're monitoring atomic clocks or using hypersensitive photometric equipment, you wouldn't detect the event. 3. Self-healing simulation. If this is a simulation, the system might restore the corrupted data, overwrite the short-term memory of every conscious entity, so you remember nothing happened. But in reality, there was a glitch, one that perception can't measure. Nirvana, forgotten clues. Short unexplained incidents. Some people have reported sunlight flickering off momentarily, feeling a strange weightlessness. For 1 to 2 seconds, trees suddenly standing still, no wind, no sound. Then everything resumes. These phenomena are typically dismissed as dizziness, distraction, or psychological illusion. Orphaned gravitational waves. Some brief, untraceable gravitational wave signals recorded by LIGO have no known astrophysical origin. Could they be sensor noise or remnants of an event that flickered in and out of existence? Or could it happen again? No one knows. There is no known technology today that could recreate such an event. No instruments have ever recorded a sun-off-on transition. No physical model describes a star undergoing momentary existence interruption. But if it did happen once and no one noticed, who's to say it won't happen again, tomorrow, or even right now? Not for the sun, not what we truly understand. The sun, our source of light, energy, and life, remains a star we've never truly touched. We observe it, we measure it, we analyze its radiation. But the structure, the nature, and the true rollings of the sun within the universe remains incomplete. If just 1 second of its absence can disrupt orbits, alter climates, create gravitational ripples, and trigger cascading unknowns, then could a single cosmic blink be enough to rewrite everything? It's your burn. Final question. What would you do if one day, while walking under the sunlight, the light went out for exactly 1 second? Would you believe in a crack in reality, or just chalk it up to the imagination of dreamers? Leave your thoughts in the comments below. Thank you for watching and listening. Don't forget to like and subscribe to keep exploring more mysteries in our next videos.